You recently watched a video where we were taking a data set of the hourly wages of various high school students, and we were finding different measurements from that, and you see these measurements over here. We also took this data set and we turned it into a pretty picture, a line plot and a box plot. And during that video I explained that a lot of these calculations can be carried out by Desmos, so that's what I'm going to show you here today. So by the way, this data set that you see on the left, over here on the right, I put it in order, and I've shaded the top half and the bottom half, and you will tell that the right in the middle, the number that would be smack dab in the middle, in this case is 10.5 because it's right between the 10 and the 11, is the median. Well, let's go to Desmos and see how we can get these figures. If you start with a brand new Desmos sheet, instead of typing a y equals equation in here and getting a graph of your function over here, we're going to do something different. We're going to click on Add Item, and we're going to choose a table. Now normally in a table you would put an x and a y value, and you would get an ordered pair that would show up on the graph. But we don't care about that. We're just going to start entering our data into the x portion of the table. Just take any data piece, any number that you want, type it in and hit enter. And after I've done that whole thing, I have this table over here. I'm on a new Desmos sheet that I made ahead of time. So you'll notice there's no graph or anything. We don't care about that. We just care about this data set. So now from that data set, how can we get all of these different measurements that we're looking for? So you go to a new y equals. Here I'm in rectangle number 2. It's where you could enter another equation. But instead of doing an equation, we're going to access the stats part of Desmos. To access the stats part of Desmos, click on the keypad part, and over here you will see a choice over on the right for a bunch of different functions. I'm going to click on functions, and at the top of that you've got different possibilities, and we are going to end up using stats. So when I go with stats, I'm taking the, in this case, let's say I wanted to find the median of that whole data set. I would click on median. Now here's what you have to do. They offer you some parentheses. You say list x1. So you type in an x and a 1 and it'll give you that subscript. And boom, you can close your parentheses, but you already see that it's calculated the median for you. You could do this with average. So you go ahead and you go over to functions, and we're in stats. Average is also mean or average, same thing. And you say, hey, you're interested in x1, and it calculates it for you. The quartiles are a little trickier. I'm now in a new rectangle. I go to functions, and I'll choose quartile. Be careful because there's quantile. I choose quartile, and I have to tell it that we're working in list x1, and then comma, do I want the first quartile, which is the marker of the bottom 25%? Do I want the third quartile, which is the marker that gives me 75% below, 25% above? I'll go the first quartile, and it's 9. You see it always displayed right over here. And just for giggles, let's find the third quartile. Choose quartile, the list x1, comma, I want the third quartile, 13.5. And by the way, you see that the median is 10.5. The median is the center of your data, meaning 50% of the data pieces are above it, 50% are below. Well, if I thought of that like a quartile, that would be the second quartile. And so I go to quartiles, list x1, comma 2. The second quartile means 50% of the data pieces are below it, 50% are above, and I get 10.5, the same thing I got with the median. So that's how you can use Desmos to find these different measurements, and things like range and interquartile range you would do on your own. Remember, range is the distance between the biggest data piece and the smallest data piece. Interquartile range is the distance between your third quartile and your first quartile. And then the maximum and the minimum you can usually find just by eyeballing your data, what's the smallest and what's the largest data piece. And since you've stuck around so far, let me show you a little secret, but of course, keep this a secret. We don't want word getting out about this. I'm going to go to Functions. Now instead of choosing Stats, which we've been working with, I'm going to choose DIST, which stands for Distribution. And I'm going to choose Box Plot. We learned how to make a box plot, and we're working with list X1. Holy cow, it just built the dot plot for us. Now in this case, the Desmos decided that that data piece of 24, that one student who was making $24 an hour, was an outlier. So Desmos excluded that data piece from our dot plot and made the dot plot out of the rest of the data. And by the way, as you would guess, if I go back there and I go to Functions, Distribution, Dot Plot, say I'm working with list X1, boom, there's my dot plot. Kind of nice. Thank you, Desmos. And finally, to finish up, I want to reiterate a previous point, and that's the difference between the mean and the median when we have outliers. So over here in the green, I've made up a new data set, and let's pretend this is the salaries of a various group of people. And here we have some regular old salaries, and then this person has struck it rich, making $486,000 a year. Now I haven't put this in order, but I would have to put it in order from least to greatest or greatest to least to physically count out the median, but I have the spreadsheet do it for me. So the median of this data set is 66,000, but the mean is 121,000. The reason the mean is so much greater is because this outlier really influences the mean, but it doesn't influence the median by much. If I take that 486,000 out, so it's the same data set, but now I don't have that massively large value. Again, it's not in order from greatest to smallest or smallest to greatest, but notice taking out the big outlier, the median has not changed by much. It went from 66,000 to 61,000. However, the mean has reduced by about $60,000. So this one outlier piece of data gave the mean kind of an artificial influence of about 60,000. This is why in many data sets they will take a giant outlier piece of data or a super tiny outlier piece of data and remove it when doing the analysis. That's it.